Sorry about that, guys. This is chapter 4, number 20. What we started was we organized our data. So we had 143 with positive test results. And so positive, we had a total of 143. 23 were false positive, which means they don't use it. So we determined 143 minus those 23. 120 actually used it and had a positive test result. We did the same thing with the negative column. We then added up all of our data to say we had a total of 299. Remember, you have the sum down here if you just select the data. And so how many did not use marijuana? Did not use is the 23 plus the 151 for a total of 174. The probability of randomly selected subject did not use marijuana. That's going to be the 174 divided by 299, which is 0.581. 9, that one's going to become a 2 because it's a 5 or above next to it, 0.582. All right, so for a problem like this, for a given pair of events A and B, complete parts A and B below. When a page is randomly selected and ripped from a 23-page document and destroyed, it is page 20. So 1 out of the 23 pages was destroyed. When a different page is randomly selected and ripped from the document, it is page 9. So now another page is ripped out. So when I had that 1 out of 23, I only had 22 pages left, and one of those was ripped out. Determine whether the events A and B are independent or dependent. If the two events are technically dependent but can be treated as if they're independent according to the 5% rule, consider them to be independent. Well, these are dependent events because it depends on the first one getting ripped out. So in order for the 5% rule to apply, what's going to happen is I had 2 pages destroyed out of 23. If I go into Excel, 2 divided by 23 equals 0.0689. I could have done that in a calculator too. 2 divided by 23, 0.0869. It doesn't matter which way you do it. But what it does tell me is I cannot apply the 5% rule. I have to consider them to be dependent. And so then they want to know the probability of A and B that they both occur. So what I have to do is I have to figure out the probability the first one occurs. The probability the first one occurs is 1 out of 23, 0.043478. Then the probability the second one occurs is 1 out of 22. 1 divided by 22 is 0.045. In order to figure out the probability that they both occur, I need to multiply them together. If I multiply 0.043478 times 0.045455, I am going to get 0.001976, rounded to 4 decimal places this time. So 1, 2, 3, 4. I'm at that 9. I look to the right, it's a 7. That 19 is going to become 20, 0.0020. All right, so for this one, accompanying table contains results from experiments with the polygon instrument. So you got to click on this icon to get the data. I'm going to click here. You can open in Excel. As we go through, the probability all 4 test results had true negative results when they're randomly selected with the replacement. So what we're going to do there is we have to figure out how many total we had. So we had 81 total, and so I could find that there, or I could find that here. Or I could add in a calculator 5 plus 21 plus 42 plus 13. True negative is when they did not lie and it was a negative result. 42 out of the 81. With replacement, 42 out of 81 times 42 over 81 times 42 over 81 times 42 over 81. That becomes this really big number divided by this really big number, which is 0.0722. Rounded to 3 decimal places, it's just 0.072. Is such an event unlikely? No, because the probability of the event is greater than 0.05. The probability all 4 test subjects had true negative results selected without replacement. That means 42 out of the 81 is the first probability I'm going to multiply together. Then what's going to happen is I don't have that 1 anymore. So 42 becomes 41 because it's not replaced. The 81 becomes 80. 42 over 81 times 41 over 80. But we're doing this 4 times. The 41 becomes 40. The 80 becomes 79 because that one's not replaced. And the 40 becomes 39. 79 becomes 78. 42 over 81 times 41 over 80. times 40 over 79 times 39 over 78. And when I divide my numerator, divide my denominator, 0.0672 or 0.067 rounded to 3 decimal places. Again, this is not unlikely because it's greater than 0.05. So as you do this, remember when we're multiplying fractions, we multiply across all of our numerators, and then we multiply by all of our denominators. To turn a fraction into a decimal, what do? We divide the numerator divided by the denominator. And so that's where this the numbers come from. So here's one you want to read carefully as well. You have to read them all carefully, but identical twins come from a single egg that split into 2 embryos, and fraternal twins come from eggs that are from a separate fertilized eggs. Also, identical twins must be of the same sex, and the sexes are equally likely, and sexes of fraternal twins are equally likely. If a pregnant woman is told that she is going to give birth to fraternal twins, the probability she'll have one child of each sex. Use the table. So what's the probability? With the fraternal twins, a boy and a girl or a girl and a boy. And so we're going to click here, open in Excel. First thing I'm going to do is create a total column. I'm going to add up all these to get 12. I'm going to add up all these and get 34. Next thing I can do on this question, get rid of identical twins. They give me information about it, but the question is not asking that. The question is asking the pregnant woman's told she's going to have fraternal twins. So I only care about the 34 fraternal twins here. The probability one of each sex. Well, 7 are boy, girl, 7 are girl, boy. So that's going to be 14 out of 34. So I have 14 over 34. Remember, when I have fractions, what do we have to do? In order to reduce the fraction, we can divide the numerator and denominator by the same number. If I divide both of these by 2, what am I left with? 7 over 14. So there's my 7 over 17. That's going to be my simplified fraction. 14 divided by 2 is 7. 34 divided by 2 is 17. So as you go through these, just make sure that you reduce the fractions if you can, if it asks for a fraction. So this question starts asking about combinations and permutations. This is where, if you hadn't started looking at this part of it yet, go into the textbook. And what it's going to tell you is the difference between combinations and permutations is when order matters. So horse racing, a trifecta is a bet where the first 3 finishers in a race are selected. And they're selected in the correct order. So because the order of the first 3 finishes does make a difference, it's a permutation. If order did not matter, it would be a combination. So my textbook's opening up. So I just want to show you, as you go through, we're going to go through the pages because we haven't done this for a little while. We're looking for what? We are looking for something bold. So permutation rule, items are different on combinations. And so you see here, permutation order counts. Combination order does not count. So even though we're not in the official definition, we're still getting what we need from this piece of it. So here, a fan of country music plans to make a custom CD with 11 of her 30 favorite songs. How many different combinations of 11 songs are possible? Is it practical to make a different CD for each possible combination? And so how many different combinations of the 11 songs are possible? So we need to do a combination. What I'm going to recommend to you is to use this calculator. It's at StatsCh4Part2. And so I'll post this with the videos. So my goal here is combinations because order doesn't matter. There's 30 total songs and she wants to choose 11 of them. And then when I hit calculate, I'm going to get 54,627,300. And so if I needed to do a permutation, I could also do a permutation in here. And so when I go back to my homework, there's my answer. Now, it's not practical to make a different CD for each combination because it's kind of large. 54 million? That would be a lot of CDs. When 4 basketball players are about to have a free throw contest, they often draw names out of a hat to randomly select the order. What is the probability that they shoot free throws in alphabetical order? Assume each player has a different name. So remember with probabilities, the numerator is the number of like positive outcomes. So how many ways can they be in alphabetical order? Only one. How many orders can they be? Well, there can be 4 factorial for the orders. In order to do 4 factorial is going to be what? 4 times 3 times 2 times 1, which is 24. One out of the 24 ways that it can be chosen would be alphabetical. So many newspapers carry a certain puzzle in which the reader must unscramble the letters to form a word. How many ways can the letters L-E-Z-B-A be arranged? Well, there's 1, 2, 3, 4, 5. So that's 5 factorial. And so this is small enough, so I can do 5 times 4 times 3 times 2 times 1, which is 120. So 120 different ways. And so what is the correct unscrambling of L-E-Z-B-A? Well, the word that's going to make sense, blaze. And probability coming up with that, well, there's one correct and there's 120 different ways to do it, 1 out of 120. So this is chapter 4. I hope that it helped a little bit. Few different things going on here. We had some set theory. We had a little bit of probability, combinations, permutations. Good luck this week, and we'll talk to you soon.